Good afternoon, everybody. Today we will study complementary symmetry class B push pull power amplifier. We have done class B push pull power amplifier. The addition is complementary symmetry. Now, why it is called complementary symmetry? Because in this circuit there are two transistors Q1 and Q2. As you can see, Q1 transistor is a NPN transistor and Q2 transistor is a PNP transistor. Okay. Now, the working of this circuit. We know that this is a class B power amplifier, and in class B power amplifier, Q point is where? Q point is at cutoff. Okay. So the conduction angle is 180 degrees. 180 degrees conduction angle. Okay. Now if two such transistors can be used, so one half cycle will get from the one transistor and another half cycle will get from the another transistor. In this way we can get the full cycle that we have already discussed. Here also the same thing is done, but the important thing is the two transistors should be same, means their characteristics should be exactly same and complementary, as they are NPN and PNP transistor. So during positive half cycle of the input is applied over here to the base of the two transistors. When V in is positive, then as we can see, Q1 is on and Q2 is off, and we will get the output positive half cycle, this thing. Okay. When V in is negative, that is when for the negative half cycle Q1 is off and Q2 is on, and therefore across the load we will get the negative half cycle. Okay, this is fine, but there is a problem. The problem is very important and it is called crossover distortion. Crossover distortion. Now what is this crossover distortion? It is seen that in the output is not like this. Output is not like this. Okay, rather the output is like this. Like this. That is, at this point there is no current flow through the transistors, both the transistors. This is called crossover distortion. Okay, now why it is happening? We know that a transistor operates, any transistor operates or turn on when the voltage across it is 0.7 volts. Okay, therefore the transistor Q1 will be on for voltage greater than 0.7 volts. Similarly, Q2 will be on for voltage 0.7 volts, that is minus 0.7 volts. It means between 0.7 volt and minus 0.7 volt, both the transistors are off. Okay, so I can write it like between plus 0.7 volts and minus 0.7 volts, both the transistors, that is Q1 as well as Q2, are off and no current flow through this. Therefore we will get no output at that time. Therefore the output will become like this. Suppose this is 0.7 volts and this is minus 0.7 volts. So above 0.7 volt T1 will be on and below 0.7 volt, T2 will be on, but between them there will be no current, means this will be like this. It means from here to here the current will be like 0, and therefore this type of thing is obtained, which we are calling it crossover distortion. Between this T1 and T2, or Q1 and Q2 are off. So this is happening, and this is known as crossover distortion. Thank you.